Hello everyone, I welcome all of you to the third session on pointers. Sir, is it third session? Yes, I have discussed two sessions already. What is that I have discussed in the first session? Yes, I have discussed how do you declare and how do you initialize the pointers, and also what is the use of pointers. That is the most important session with respect to the pointers. Please go back and check again what is that I have discussed in the first session. In the second session, what are the operations that I can perform with respect to the pointers? For example, the last topic that I have taken in the previous session was do's and don'ts with respect to the pointers. Sir, what is this do's and don'ts? Can I perform the addition operations with respect to pointer? Can I perform subtraction operation with respect to pointer? And what are all the different arithmetic operations that I can perform with respect to pointers is what I have discussed in the last session. So please go back and check, have a quick glance with all the first session and the second session topics. So please, I welcome all of you to the third session, guys. So this is one of the important and last session of this pointers topic. So let me start the session. In the session, guys, I will be discussing some of the topics with respect to the pointers as a function parameters. That is one of the hot topic in this chapter. And also I will be discussing memory allocations of pointers. This is an important 2 marks question. Is it 2 marks question? Can I get 2 marks question in this chapter? So please keep that also in mind. No. So I will get 1 marks and 3 marks question. So you should expect it for 3 marks. This is one of the important question for 3 marks. So please make a note of it. And also I will discuss about the dynamic memory allocation. So along with that, this is also an important question with respect to your exam point of view. The difference between static and dynamic memory allocation. So you can expect this question in your paper. Okay. This is one of the important topic. Along with that, pointers and objects. Oh, somewhere I have heard this word, sir. What is this objects? So please recollect the concept of objects. I will discuss this topic again. And pointers and functions. One more important topic. Invoking functions by passing the reference as well as by passing the pointers. Guys, this is also important question. In this session, I have got lot of important questions. So guys, in the first session, whatever I have discussed, that is the basic things. You will get most of the 1 marks question. In the second session, I have tried to give you the idea of implementation, where exactly we implement the pointers. In this third session, so I have tried to cover all the important concepts that you will get in your exam. So guys, all the topic, whatever I'm going to discuss today is important for all of you. So let me start with the first topic. Guys, we have pointer as a function parameters. What is that I have? Pointer as a function parameters. I have taken a function that is swap. What is this, sir? I have defined a function to swap the given numbers. So let me not discuss the logic what is there in this function, but I will tell you what is that I have done here. So guys, this is what I will call it as a parameters. So this is what I will call it as a arguments. Please remember that. So guys, I am just passing the pointer as a parameter. Just keep one thing in mind. Okay, suppose if I don't have the pointer, so what will be my code look like? So how will be my code looking like? So guys, please observe, what is this void? So void is a return type. What is this void? Void is a return type. What is this swap? Swap is the name of the function that I have given. So inside that parenthesis, I have 2 variables, that is m and n. So now you have to think, what type of variable is this? What is the symbol that I have used here? Asterisk. Suppose if I use asterisk, so you should treat this as a pointer. If it is a pointer, please remember. So what is that the pointer is holding? So pointer is holding the address of the variable. Address in the sense what? The reference. So it means to say that I am not sending the value to the m. instead of I'm sending the reference. I'm sending the reference of that particular variable. How are you sending the reference, sir? Here, please observe, guys, what is that I have here? So here I'm sending ampersand num1, ampersand num1, ampersand in the sense what? This is the address. This is the address. Ampersand num2 is what? So if I use ampersand, so it should be address. Address of these two variable, I'm sending it to m and n. What m is holding? M is holding the address of num1. N is holding the address of num2. So in other scenario, if I'm not using the concept of pointer, so I would have passed the value. I would have passed the value, but here I'm passing the address. Here I'm passing the address. It is very easy to remember. So if you are using this function as a normal function, so you are not writing this star. That's it. You're not writing this star. If it is a normal function, you would have not written this ampersand. That's it. Here you should add the ampersand, here you should add the star. So that's the simple way to remember if you're finding it very difficult. What is that you have to remember? You should add 2 star, here you should add 2 ampersand. Those who are finding it very difficult, for you guys, what is that you have to add? You have to add 2 ampersand. So you have to add 2 star. Those who have understood the topic, for you guys, why should I use ampersand? Because I'm just sending the address, not the value. So what is that I'm trying to store here? I'm trying to store the address of num, and I'm trying to store the address of num2, num1 and num2. That's the concept with respect to the function as a pointer. So guys, here also wherever I'm using the m and n, okay, so I am just using the pointer variable star m star n. Wherever I'm using, here you can just check. So I'm using star m and star m and star n. So here also I should use star n. Okay, so that's the concept that you should remember with respect to pointer as a function parameter. Pointer as a function parameter. If you come to that particular word, pointer as a function parameter, so it should be your parameter, right? So what is that you have to do to make it as a parameter? So already it is a parameter. What is that you have to do? Make it as a pointer. You just have to add star. That's it. If you just add star to your parameter will become a pointer. That's all about the pointer as a parameter in function. Moving on to the next concept. Very important topic with respect to your exam point of view. Yes, memory allocation is done in 2 ways. What is this memory allocation, sir? Come on, listen to me. Memory allocation in the sense, I will declare a variable. As soon as I declare a variable, for example, I will just take int a. So if I just write like this, for this variable, I have to allocate some memory. So how do I allocate the memory for this variable? I have 2 ways is what I'm trying to discuss now. So in 2 ways, I will allocate the memory for this variable. So what is the first way that I have? So first one is static allocation of memory, and the second one is dynamic allocation of memory. How many types of memories we have? Yes, we have static allocation of memory. Another one is dynamic memory allocation. So guys, what is the difference between static allocation and dynamic allocation of memory? So that is what I'm going to discuss in detail in this session. So guys, before that, dynamic allocation of memory, before I start with the dynamic and static, I should know some of the basic thing. What is the basic thing that I should know? Please look at me. Yes, what is that I should know? I should know something about new operator. What is this new operator, sir? Can you tell me? Yes, new operator will help me to allocate the memory for a variable. I will repeat. New operator will help me to allocate the memory for a variable. Sir, what is this? How do I allocate the memory for a variable? Please look at the syntax. So first imagine I am writing the data type. What is the data type here? I have integer. So for this integer, I am trying to write a variable. Is it a normal variable that you are trying to create? No, I am trying to create a pointer variable. Why? How do you know that that is a pointer variable? Because you have star. So after that, so please observe here, I am allocating the memory. For the p number. P number is a pointer variable. How are you trying to allocate the memory for this p number? How are you trying to allocate the number for this p number? Please observe, I am trying to use a keyword called new. I'm trying to use a keyword called new. Variable name is equal to new, and then after that you have to write the data type, and after that you have to write the data type. That is what you have to use to allocate the memory for any variable. So what is the keyword that you are trying to use? You are trying to use a keyword called new. So this new keyword will allocate the memory for this variable. So you have to mention what type of data that you are trying to store by specifying the data type at the end of the statement. So this is the syntax to allocate the memory for any variable. What is that? So you use new operator to allocate the memory for any variable. You use new operator to allocate the memory for any variables. So fine, here you are trying to create what type of variable? You are trying to create the pointer variable. How did you got to know? Because you are using the star. Because you are using the star. In the same way, sir, I want to create one more pointer variable, right? Can you just show us? Yes. First, what is that I am trying to write? I am trying to write the data type. Then after that I will write a variable. So can I make it as a pointer variable? Yes. How do you make it as a pointer variable? So you just have to add star. You just have to add star. Then after that, allocate the memory for this variable, sir. Yes. What is that I have to write? I have to write the name of the variable. What is the name of the variable? A is equal to, what is that I have to write? I have to write a keyword called new. I have to write a keyword called new. Then after that, I have to write the data type. What is the data type? Int is the data type. Then after that, semicolon. This is how you will allocate the memory for any variable. So you have allocated. So after the execution of the program, you have to delete or deallocate the memory. So what is that? How do you do that? So using the keyword called delete, using a keyword or an operator called delete, so you will delete the allocated memory. So what is the syntax for that? So please observe, delete variable name, that is pointer variable name. So what is the keyword that you'll use? Delete and pointer variable name, whatever the variable that you have considered to allocate the memory, the same name you will write. For example, in the previous example, I have taken A. So what is that you will write here? So guys, I have delete IPTR instead of that. So what is that I will write? Delete A is what you will write here. Delete A. So this line will allocate the memory. This line will allocate the memory. This line will deallocate the memory. So within two lines, you can allocate the memory and you can deallocate the memory. So hope you learned, right? So how do you allocate and how do you deallocate? Yes, I am throwing a challenge for all of you. Guys, I just need only 10 minutes. Exactly concentrate 10 minutes. From now, whatever I discuss, I'm sure all the important questions will come in the exam. So try to concentrate from now onwards. It's very, very important. I will discuss all the important topics in this chapter. Moving on to the next one. Guys, I'm trying to discuss the difference between the static memory allocation and dynamic memory allocation one by one in detail. So each point makes a lot of sense. Please listen to me. So memory space. I'm starting with a static memory allocation first. Memory space is allocated before the execution of the program. What is that? Memory space is allocated before the execution of the program. Imagine you are trying to write the exam. So before you start writing, so they will give you the answer scripts. Okay, what is that? So before you start writing the exam, they'll give you the answer scripts. So once you take the answer scripts, if you want additional sheets, they will not give you. So what do you call that as? That is static. What do you call that as? That is static. The answer scripts, whatever you are trying to take, so whatever you have, that is what I will call it as a memory. So within that answer scripts, you have to write whatever you want. If you find it shortage, it is your problem. That is, I cannot help it with the static memory. I cannot help it with the static memory. Suppose if you have extra sheets, again, that is for you only. I will not take it back. So this is what we call it. This is the concept, is what we call it as a static memory allocation. What is static memory allocation? Memory space is allocated before the execution of the program. Before the execution of the program. That is what I will call it as a static memory. Opposite to that is a dynamic memory. So here, before the execution, you will allocate the memory. Here, during the execution. During the execution. Observe, not after the execution. This is during the execution. You are executing the program. You are writing the exam. So during that, I will give you the sheets. I will allocate the memory. That is what you have to understand. That is what we call it as a dynamic memory allocation. Whenever you come across with a word called dynamic in programming, so one thing you have to remember, dynamic in the sense under the execution of a program, static in the sense before the execution, dynamic in the sense while you are executing the program. So here static in the sense before you execute the program, so you will get the memory, but dynamic during the execution of the program you will get the memory. That is the first difference that you have to understand with respect to static and dynamic. What is the second point that I have? Memory space allocated is fixed, as I told you in the beginning with an example. How many sheets that you will get before you start the exam, that is fixed. After that, if you want extra, I will not give you. So that is what you should remember. But in dynamic, it is not like that. In dynamic, it is not like that. If you want the additional sheets, how many additional sheets you want? So that many additional sheets will be provided until you complete the exam. So in the same way, the dynamic memory allocation, memory is not fixed. Whatever the memory that you need until you complete the execution of the program, so the memory will be supplied. So that is what you have to remember. So what is the point? So the memory space allocated is not fixed. The memory space which is allocated is not fixed is the second important point with respect to dynamic memory allocation. So what is the third point that I have? More memory space is required. More memory space is required. Why it is like that? So please imagine you are sitting in the exam and I will tell you that you have to collect the additional sheets. Later if you ask me, I will not give you. So what you will do, to be in a safer side, you will ask one sheet extra. Yes or no? You know that you will be completing your exams within 25 sheets. But so what you will do, oh, let me just take 2 sheets extra because I know he will not give me if I ask him at the end moment. So that is the thing that you are thinking. So that is a concept that you are thinking, right? So that is the reason, guys. So here also, whenever I am allocating the memory for a program, I have to allocate more memory. Memory management is not efficient in this type of memory allocation. So when it comes to this, less memory space is required. Why? Because if it requires the memory again, so the memory can be allocated. That is the most important point that you should remember. What is the next one? Allocation will happen from stack area. Please observe. Allocation will happen from stack area and allocation will happen from heap area. There is 2 different areas. One is let me not take that example. I thought of taking one example. Okay, one is stack area, another one is heap area. What is the stack area and heap area? So this is the 2 different locations that memory is being stored, and the distribution of memory will happen in different ways. Okay, so whenever we are using a static memory, we are using the stack area. Whenever we are using the heap, okay, we will be into the dynamic allocation. So that is what the 2 different points that you should remember. So what is this stack and what is this heap? I will be discussing that in detail in the data structures. Okay, what is stack and what is heap? This is the 2 different types of data structure that I have. So I will be discussing that on completely in detail in the data structure chapter. As of now, you just have to remember, if I say the word static, so you will remember what? Yes, you will remember the stack. So if I say the word dynamic, you should remember heap. Okay, so moving on to the next one, this is one of the important questions that you should remember. You will be asked to write for 3 marks. Okay, hope it is very simple and easy to remember. Okay, the next one, guys, free store. Okay, here I'll be talking little about the heap memory. Okay, so I have 2 different types of memory. Okay, let me just give you a brief knowledge about heap memory and memory leak. What is this heap memory? Heap memory in the sense, please observe, free store of pool. Imagine I have a pool. Okay, so I have some set of mobile phones. Okay, what does that have? I have a pool. Let me just take one more example. I have instead of pool, I have a bucket. Okay, inside that I have some 10 mobile phones. I have 10 students. The first and second bench students, they are very curious to talk to their girlfriends. Okay, but they don't have mobile phone. We don't allow in mobile phones in our college, right? So they are very eager to use the mobile phones. So like that, I have 4 more students. So only 10 mobiles I have. First 2 benches, I have already 10 students. So they will come and they will take the mobile phones. I don't have the mobile phones for the next 4. So what is that I will do? One, I will ask them, once you're done and over, please keep your mobile back in the bucket. Please keep your mobile back in the bucket. So guys, in the same way, so once they keep their mobile fine, like let's imagine first guy will finish off his talking with his girlfriend very soon. Okay, the second guy will never finish at all. Okay, so first guy, he has kept his mobile phone. So the first mobile is free now. So I will allocate it to the some other guy. In the same way, the fourth guy will finish off soon. He will come and keep it. I will allocate it to the next guy who is pending. So like that, I will allocate the mobiles, so which is already used, which is in the free pool. So this bucket is a free pool. Once you are done with the using of that mobile phone, you will return it back. In the same way, you treat this mobile phone as a memory. I will allocate the memory to all of you guys, those who are executing the program. Once you are done with the execution, you will return back that memory to the free pool. So whatever the memory that I have, I will have that in the free pool. Suppose if you want to execute another program, take this memory and use it. Once you are done, you give it back. This is what I will call it as a free pool. Where exactly I store the memory, so that is what I will call it as a free pool. This concept is what I will call it as a heap memory or free store. The next important thing that you should remember is memory leak. What is this memory leak? Please observe. Memory leak in the sense, imagine I have allocated one mobile phone to the student number 1. So he will be keep on using that mobile phone. What will happen? So after his talk with his girlfriend, so he should return it back. Yes or no? Yes. He has finished talking with his girlfriend, but he will not return it back. So in my accounts, what it says, so I have given to the first student, but he has completed his talking to his girlfriend. No, he is not talking to her anymore. Okay, he is finished his talking. So, but here it shows he is talking, but there he is finished and he left for the day. So where is that mobile phone? The mobile phone is orphan now. Mobile phone is orphan now. Yes or no? He has kept it somewhere. He has not returned it back to me. So imagine this example. Again, the same thing will happen for memory also. He is a program now. I have allocated a memory to him. He has completed his execution. He has completed the execution. So he should return back the memory. Yes or no? He has completed its execution. He should return back his memory, but he has not returned, but he has completed its execution and has gone. So the memory, whatever I have allocated in my accounts, it shows that I have allocated to him. But he is not executing currently. He has gone off. He has terminated the execution of the program. What happens to that memory? That memory will not be considered here in my statistics. If you ask me what is the amount of memory that you have, I cannot say that I have this many memory because it does not come to me. So I cannot take it to accounts, and also I cannot say that he is using it because he is not using it right now. He has completed his execution. So what will happen to that memory? That memory is orphan now. That memory is orphan now. So such memories, I will call it as a memory leak. Such memory is what I will call it as a memory leak. The memory which is not in my accounts, okay, and also it is not used by the program. It is not used by the program. It is not returned back even after completion of execution. Such memories, I will call it as a memory leak. Such memory is what I will call it as a memory leak. So guys, these two topics are very, very important. They'll ask you for 1 mark. Okay. The next, pointer as an object. This is very simple. So remember, we discussed in the first chapter when I started the online classes, that is classes and objects. How do you create the object? You're asking what is object? Yes. Please go back and check my first session on object. So what is that? What is the syntax to create the object? Yes, come on, everybody. So I have class. I have class name I have to write. What is that I have to write? I have to write class name. Then I have to write object name. Okay, yes, I have to write the object name. Fine. This is the syntax to create any object. Fine. Let's imagine my class name is student. My class name is student. Suppose if I want to create the object for the student class, yes, one. Okay. Now what is the topic? Pointers and objects. So how do I create the object as a pointer? So just simple thing that you have to write. So you just have to add star. Just have to add star to this pointer. So this will be treated as a pointer object. This will be treated as pointer object. That is what they have given. That's it. You don't have to think much about it. What is that you have to add? You just have to add star to the object name. That's it. So if you do that, the object will be converted as pointer object. Object will be converted as pointer object. Moving on to the next topic. Very important topic. This was repeated twice in the previous year papers. What is that? Pointers and functions. Under this topic, we have some important topics. A function may be invoked in two or more ways. What is functions first of all? Functions are the set of lines or the block of code which performs one task. We have already discussed that, right? So I have to invoke, I have to make it active. Okay, how do I make it active? Only when I call it will be active. Yes or no? Yes. How do I call that? How do I make it active? So that is very important. In two ways I can call that. Okay, the first one is call by value. The second one is call by reference. You are trying to call that function by value. If you send the values, the function should get activated. The function should get executed. That is first thing, that is call by value. What is the second one? Call by reference. What is this call by reference? The function will get activated or the function will get executed if you just send the reference of the parameters or the arguments. So please understand, you are trying to activate the functions by two things. One is by value, another one is by reference. One is by value, another one is by reference. I'm not discussing much in detail about this call by value because you have already studied in the first PUC. But now in this chapter, I will be discussing in detail about this reference. What is this reference? Call by reference. Guys, call by reference in the sense, please observe. By passing the reference, point number one. You are calling the function by passing the reference, by passing the parameters. That is the second thing. In reference, you have two things. One is, what is the first one that you have? You have by reference. You are calling the function by reference. The second one, you have pointers. Two things you are trying to use. So let us understand how exactly invoking a function by passing the reference, how exactly this is happening. So let me just write a simple code for all of you. So what is that? You have to write void swap. So what is void? Void is a return type here. Swap is a function name that I'm trying to write. Okay, this is a function definition that I'm trying to write for all of you. And then I have a function call. What is the function call? So I should have the function name followed by the parameters. Yes, yes, right. So whatever the parameters that I have here, I will call this as an actual parameter. So what is actual parameter? The parameters you have in the function call. So that I will call it as an actual parameter. The parameters that you have in the function definition, that I will call it as a formal parameter. So what happens if you are invoking the function by passing the reference? So the formal parameter will have the reference of actual parameter. It will not have the value, but it will have the reference. The same thing, just remember. So I will explain the next concept also. By passing the pointer, if you try to invoke, what will happen? If you are trying to call or if you are trying to invoke a function by using a pointer, please read this carefully. When a pointers are being passed to the function, when a pointers are being passed to the function, how do you pass? In the function call you will pass. Okay, listen to me carefully. The address of the actual arguments in the calling function will be copied into formal arguments. Address of the actual parameters. So guys, address of this actual parameters will be copied. It is not using it as a reference. Here it is using it as a reference. But here when you're trying to send the pointers to invoke, what will happen? Address of this actual parameters will be copied to the formal parameters. You are trying to copy here, but in the first method, when you are trying to invoke a function by reference, you are just trying to send the reference. You are not copying anything. But in the second one, you are copying the address of actual parameter to the formal parameter. There, you are just using the address, that is reference of actual parameter to the formal parameter. But now you are trying to copy the entire reference. So that is what you should remember. This is very, very important. Guys, hope you understood the concepts, whatever I have discussed with respect to the pointers. This is one of the tricky and tough chapter that you have in the second PUC. I tried my best to make it very simple, and it will become very easy than this only if you read or watch this session again and again. More than 2 times if you watch, I'm sure that you will have all the concepts of pointers in your pocket. So guys, I have listed some of the important topics. You will have a lot of questions in your mind. So fine sir, you have explained a lot of topics with respect to the pointers. Then what is the important thing that I should read from this chapter? Where exactly I should concentrate? What is the content that I should read? So you will have a lot of questions, right? So for all of you guys, I have listed out some of the important questions from the previous paper and also the questions which is likely to ask. So guys, the first thing that I have is 1 mark questions. So all these things are the 1 mark questions. Please go through and take a screenshot of it and try to answer all these questions. I have discussed all these questions in detail. So after this, guys, I have some of the 3 marks question for all of you. Please take a screenshot of it, and this is also very, very important question with respect to 3 marks. If you guys are able to answer all these questions, 4 marks, that is 1 plus 3, 4 marks will be in your pocket. So guys, hope this session was quite useful for all of you. I will think that I have not wasted your time. So I'll be coming with the next interesting chapter, that is file handling. Till then, take care of your health. Be at your best behavior with everybody. Thank you. Bye bye.